you guys can follow along in your book as we're going over this. You probably already know types of triangles, so this will be a little bit of a review, maybe a little bit of new. It's a pretty short lesson, so you'll have a good amount of time to work on your written practice in class today. But today we are focusing on classifying triangles. So there are two ways that you can classify triangles. First, you can classify triangles by their sides, but you can also classify triangles by their angles. We've already talked about types of angles. You have obtuse, you have acute, and you have, what am I missing? Right. Okay, so you can classify triangles by their angles. Okay, but we can also do it by their sides as well. So if you look at the left chart that I have right here, this is classifying by their angles. Okay, it's called an acute triangle if all three angles are acute. Okay, it cannot have a right angle, it cannot have an obtuse angle. All three of my angles have to be acute if you're going to name it acute triangle. If it's a right triangle, it will have exactly one right angle. The other two will have to be acute. So here's my right angle here. The other two are acute, which means they are less than 90 degrees. For obtuse, I can only have one obtuse angle. It's the widest angle in the entire triangle. The other two are going to be little bitty. Those are going to be acute. Okay, everybody with me so far? If it's acute, what does it have to have?
It's the 93.
Three
acute angles,
which means all three angles are less than what?
90 degrees.
90 degrees, good. If it is a right triangle, it has to have exactly what? One
right angle.
Right angle. The other two have to be acute. And if it's obtuse, there's going to be exactly one good obtuse angle. The other two will be acute. Okay, if I want to show you something really quick. If I were to draw a triangle that had an obtuse angle like this, could I have another right angle? No, it's not going to make a triangle. It's impossible. That's why there's exactly one obtuse angle and the other two have to be acute. Okay, what if I had a triangle with a right angle? Could I have an obtuse angle in that? No. Again, it has to be exactly one right angle and two acute angles. It's the only way you can close that figure to make a triangle. Talk about sides. Do y'all see these little marks right here? Anybody know what they're called? Starts with a T. Sometimes you find these little critters on deer or outdoor, like in the wood. Yeah, tick. These are called tick marks. Okay, I know it sounds funny, but a tick mark shows that each of these sides are equal. Okay, so if it has one mark here, one mark here, one mark here, it's showing that each one of those side links is the exact same size. Down here for isosceles, y'all say that with me. Isosceles. Those tick marks are showing that these two sides are the exact same size. They are the exact same length. And then do you see any on the scalene triangle down there? Nope, because what does that mean? It has no equal sides. All sides are different. Okay, so if you look at the equilateral, I have a tick mark on every single side of that triangle, which means that all three sides are equal. For isosceles, two sides are equal, and then scalene, 0 sides are equal. Okay, how are we feeling so far? Okay, ready to move on? Okay, part it says at least 2. Oh, all three sides of this triangle are congruent. What does congruent mean? The same, okay? Which of the following terms does not describe this triangle? Okay, would it be equilateral? Which of the following terms does not describe? Is this triangle not equilateral? Or is it equilateral? It is. So this one's out. It's asking which of the following does not describe the triangle. Equilateral does describe it. Remember those tick marks? Every single one of these sides is equal. They're all congruent. It tells us that. Yes. Okay, acute. If I named this triangle an acute triangle, would it be true based on the chart we just looked at?
Yes.
Yeah, because all three of my angles are all acute angles. So that one would be true, so we would mark that out. Is it considered isosceles? Does it have at least two sides that are equal?
Yes.
Yeah, because all three sides are equal, which means that it has to also be considered isosceles. Remember, not to be isosceles. So therefore, yes, you asked if this would be a right triangle. That's correct. Okay. This is the only one that does not describe the triangle shown. There is not a single right angle in that triangle. We feel good about this so far? Cool. Okay, on your whiteboard or on a sheet of paper, I want you to draw 3 angles. Any 3 angles, not triangles yet. I want you to start with 3 angles with sides that are segments of equal length. So what does that mean? I don't care what kind of angle, but I want the sides to be as equal in length as possible. And you're going to have 3 angles drawn on your whiteboard. Okay, your angles are going to have to be spread out. You can't like stack them all together because then we're going to end up making these into triangles. Okay, so you've got 3 angles. The first angle is going to be acute. Anybody have an acute angle on their board? Good. I want to have 1 acute angle. The second is going to be a right angle. Mine aren't very straight, sorry. And the third is going to be obtuse. So I drew my random obtuse one over there off to the side first. For each of those angles, I'm going to draw a segment. What's a segment again? Uh-huh.
A line that has 2 dots at the end of
Yes, it's a line that has 2 dots. Those 2 dots mean that it continues on forever or it stops. It stops. Good. Okay, so a segment is a line that stops. It has a beginning and an end. I'm going to draw a segment between the endpoints of each one of my angles to form a triangle. So you're closing up every one of your angles and you're making a triangle. We will classify each triangle by side and by angles. So everybody find your acute angle that you drew and you just closed it up to make a triangle. How would we name that triangle? Here's my acute one right here. Okay, how would I name this triangle based on its angles? It is acute. And if all of my sides are the same, which it's hard to make it exact, but they should be equal length. If all sides are equal, how do we classify it based on its sides? Equilateral. So it's an acute equilateral triangle. Then find your right angle. Again, those side lengths should have been equal. But does it look like the angle or the side connecting the two is the same length? Or does it look a little longer?
Looks a little longer.
A little longer? So we're going to name this based on its angle a right. What could we call it if we have at least 2 sides? Yes, isosceles. Okay, so we have at least 2 sides that are equal, which means it is isosceles. So this is a right isosceles. And then the last one that we have, based on its angle, what type of triangle is it? Obtuse, for sure. And remember, 2 segments had to be of equal length to make my angle. So if at least 2 sides are equal, that means it's what kind? Isosceles also. Okay, there's only one triangle that has perpendicular sides. Do y'all remember what perpendicular is?
Yeah.
Mm-hmm.
They're the same. They're close to the same, but they aren't.
So they cross, and what happens especially with perpendicular lines when they cross each other?
They make a right angle.
They make a right angle. Which one of these triangles has perpendicular sides? Mm-hmm. The right one, because right here, if I were to extend out these lines like this, they're going to make perpendicular lines. It forms a right angle there where the lines cross. Okay, so the right isosceles is our answer for that one. How do we know? Because of the perfect square in the corner of it. How do we feel so far?
Good.
Do we need to do more practice?
Yes.
Yes or no?
No.
Let's do one more because we almost have practice. Okay, erase your boards. I want you to draw an acute angle. Both of the lines need to be different lengths of an acute angle. So mine looks like this. I drew an acute angle, but my lines are different lengths. Then close it to form a triangle. Now, we know that it's going to be, is it acute or is it right? It's acute. Okay. Are all the sides the same?
No.
Are two of the sides the same?
Yes.
Maybe on yours, not on mine. Some of yours may also not be the same, depending on how you drew it. So mine, I have 3 different side lengths. So mine would be an acute scalene triangle based on what I drew. I don't have a perfect right angle up there. They're all acute and all my side lengths are different. Okay, I want you to just look at this and name, oh, that's bad. Hold on. I want you to name this triangle on your board. Write down the name of this triangle right here in green on your board. Name it based on its angles and its sides. That's based on angle, yes, yes. Look at mine up there. Do I have 2 sides that are equal? Good. Good. Okay, based on its angle, what type is it based on its angles? Is right. I have my green one right there in the middle. So I have a right angle. So this is a right, and it's a scalene because all of the sides are different lengths. Okay, how are we feeling about naming triangles?
Good.
That chart can be found in your book with the sides and the angles that we talked about. I'm looking. Is it in your book? No. Okay. So you have on page 242 all of the triangles based on their angles at the top. And then you have based on their sides at the bottom. So do you see where you have acute, right, and obtuse kind of in the middle? There's a title. It says triangles classified by angles. It gives you definitions of each of them. And then you have triangles classified by sides. And again, this is on page 242. So you can use that page to help you when you're classifying triangles in your written practice today, naming them. Every triangle has how many names? 2. You name it based on its angles and how else? Sides. And all of that information is on page 200, what did I say, 42? Okay, 242. All of that can be found right there. Your written practice today is on page 244 to 246. Pay close attention to 2 through 4 because you need to write an equation with those before you solve them.